our task in simplifying square roots is that we want to get the number underneath the square root as small as possible, but we need to make sure that we don't in any way change the number. So just like 2/4 and 1/2 are the same thing but look different, we want to find another way to represent the square root of 50, but with a smaller number underneath the square root. And I'll tell you why we want to do that after we do an example. To do this, what we are going to need to do is use perfect squares. What is a perfect square?
All the angles and sides are equal. Wait, are you saying square?
Yeah, not like a square, like a shape square. It's geometry, so I can see how to, but like a number that is a perfect square. What does that mean about that number?
Two whole numbers. Multiply two.
Okay, so that we take a whole number times itself, and we multiply and get that number. So like 1 times 1 is 1. 1 is a perfect square. 2 times 2 is 4. So 4 is a perfect square. And it's kind of the first interesting one. 1 doesn't really matter so much because it's just 1. So, but 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And so on. We can keep on listing them. We get 36. 49 is from 7. 8 gives 64. 9 gives 81. 10 gives 100. 11 gives 121. 12 gives 144, and that's probably about as far as you would need to know or care about here. If you don't know these numbers, you probably want to list them out somewhere because they're going to be very important to you in solving all of our problems. Okay, so if you are not comfortable and familiar with all of your perfect squares, you probably just want to make a list that you can refer to while you're working on your homework. So to simplify the square root of 50, what we need to ask ourselves is which one of those perfect squares, the numbers in that list, divides evenly into 50? So what one of those numbers can I divide into 50? 25 divides into 50. 25 times 2. So I'm rewriting 50 as 25 times 2, but since 50 was underneath the square root, the 25 and the 2 are underneath square roots. Now when we take a square root of a number, what number times itself gives us that number? So what is the square root of 25? 5. So that becomes a 5 without the square root. The square root is gone. Okay, a lot of students make a mistake here and keep on writing square roots. The square root of 25 is 5. What's the square root of 2?
1. Wait.
A lot of students will think that it's 1 because it's like 1 plus 1 is 2. But what number times itself gives us 2? Nothing pretty, right? There's nothing pretty that I can multiply by itself that will give me 2. So we're just going to leave it then. We don't want any decimals in our answer. So if it's not a perfect square, we're not going to take its square root. And this is our final answer, 5 times the square root of 2. It is exactly equal to the square root of 50. So if you would type square root of 50 into your calculator, it's going to give you a decimal. Then if you would type 5 square root of 2 into your calculator, it's going to give you exactly the same decimal. So we haven't changed the number, we just changed the way it looks. Just like we could take the fraction 2/4 and reduce it down to 1/2. It's exactly the same, it just looks different. Now the reason why we would want to do this kind of comes from when calculators and computers were not really readily available. There would be these tables in a textbook that would have all the square roots listed. So it would say the square root of 1 is 1. The square root of 2 is 1.41, blah, blah, blah. Square root of 3 is, and then all the decimals for square root of 3. Square root of 4 is 2. And so on and so forth, on up through the list. Square root of 50 probably wasn't on that list because that's kind of a big number. So what we would need to do was break the square root of 50 down into smaller numbers and find out then what the square root of 2 is from the list and multiply that by 5. Okay, so that's kind of why we did this in the first place. It does have algebraically, that we're able to simplify other problems or evaluate other problems once we do this. All right, let's try another example. Square root of 300. So what is a number that divides evenly into 300 that's a perfect square? So it's in our list of numbers there on the right-hand side. 100. 100 goes evenly into 300. 100 times 3. What's the square root of 100? What times itself gives us 100? 10. The square root is gone because we took the square root of 100. So it's just a 10, not a square root of 10, just a 10. What's the square root of 3? It's not pretty. So we just leave it as square root of 3. So 10 square root of 3 is our answer. That's exactly the same decimal as square root of 300. So you can check all of your answers. If you type the original question into your calculator and then type what you think your answer is into your calculator, same thing. Different, your answer is wrong. Okay. There's no way to get the answer from the calculator, but you can at least check your answer from your calculator.
What is that?
I'm guessing a movie next door. Sometimes you'll have a number in front of the root already. We're just going to let that 3 kind of hang out and deal with the square root of 8, and then we'll worry about the 3 at the end. So in thinking about the 8, what's a number from the list that divides evenly into 8? 4. So we can write 8 as 4 times 2, and since it was under a square root, they're both under square roots. That 3 is just going to keep on hanging out. What's the square root of 4? 2. Square root of 2, not pretty, so it's just going to stay. Now we've got that 3 and 2 out front, and they're being multiplied together, so what's 3 times 2? 6. So we get 6 square roots of 2. Okay, so if there's already a number outside of the square root, just let it hang out until the end, and then multiply it by anything else that ended up not underneath the square root.
Sounds like the wind.
Sometimes you might have more than one square root in a problem. Our first step, if we have more than one, multiply them together so that we have just one square root. So we're going to multiply 6 times 24 together and put it all underneath one square root. What's 6 times 24? I don't really see too many calculators out.
144.
Awesome, 144. You did it all in your head. So you can feel free to grab a calculator. So 144 is what we get when we multiply those together. Then, is there anything on that list that divides evenly into 144? 12 times 12, which means that 144 is a perfect square, right? So the square root of 144 just is 12. No more square roots left in this problem. This one turned out to just be a nice number. Okay. Questions? I have 2 problems for you to try then. 7 times the square root of 63 and the square root of 288. I would like you to try those 2 problems, and then we will talk about them. Okay, so the first one has that 7 out front. We just let the 7 hang out. And then what number from our list divides into 63? 9. 9 times 7. Then we take square roots where we can. So 7, what's the square root of 9? 3. What's the square root of 7?
7.
Not pretty, right? So we just leave that square root of 7. And then when we have more than one number outside at the end, we multiply them together. So 21 times the square root of 7. If we would type that into the calculator, it would give us exactly the same thing as typing in 7 times 63. For 144, what's a number from the list that divides evenly into 288? 144, the number I just said. I'm going to actually work this problem in not the easiest way. So the easiest way would be to do 144 times 2. Okay, that would be the easiest way. I'm going to do it not the easiest way to show you what might happen in case this happens to you sometime. So I'm going to say, let's say I didn't realize 144 went in there, but I was working through my list, and I realized 16 goes into there. So it's 16. Okay, so let's say I didn't make it all the way to realize that 144 goes in there, but I did find out that 16 goes into there. What is 16? 4. 18 is still a pretty big number, so if you still have a pretty big number under there, ask yourself, is there anything else that goes in there? So is there anything now that goes into 18 that's on our list? 9. So I'm going to break that 18 down into 9 times 2. Well, what's the square root of 9? 3. Square root of 2 we leave. 4 times 3 is 12, so we get 12 square roots of 2, which is exactly the same thing you would get if you had realized that 288 is 144 times 2. Then you would just get 12 square root of 2 right away. So that's the fastest way to do it, but you can still get there even if you didn't realize and you chose a number higher up on the list. Okay? Questions? Okay, now